Okay, before we dig into the hidden singles, I'd like to take a moment here to point out that using candidate filters like this is not cheating. Not at all. You can do all the things that filters do by using pencil and paper, your naked eyes, and your brain. The filters only act to help you do it faster. Much, much faster. That's the only difference. So I say, why not use them? I always ask people, if you have 30 minutes to do some Sudoku puzzles, would you rather work on one puzzle and probably not even finish it, or would you rather solve 5 or 6 puzzles in the same amount of time? Because it takes me 20 or 30 minutes just to fill in the candidates when I happen to do a puzzle in the newspaper, like when I'm traveling to kill time on an airplane, for instance. And the puzzle ends up looking like a mess with all the scribbling, and I hate that. Anyway, filters are a great asset and a great tool to help you solve the puzzles, and I highly recommend using them if you can. A hidden single is simply a candidate that is the only possible solution to a particular cell, but it's camouflaged by the presence of other candidates, and you have to weed it out. Unlike a naked single, which is the only remaining candidate in a particular cell and is very easy to find and very easy to see. Before we start, let me show you a little trick, especially for those who do not have candidate filters. Notice how the candidates are normally arranged 1, 2, 3 across the top, 4, 5, 6 in the middle, and 7, 8, 9 in the bottom. And then vertically, they are 1, 4, 7, and then in the middle, 2, 5, 8, and then on the right, 3, 6, 9. So what I do is I zero in on 3 candidates at a time. For instance, I'll look at the 1s, the 2s, and the 3s in a row, and I'll go across that row, and then I'll do the next row, and then the next row, and the next row. I'll do all 9 rows looking only at 1s, 2s, and 3s, and when you scan them, you can immediately see if there's only one of those 3 in that row, and then you know that that's a single. And then you scan the 4s, the 5s, and the 6s and go across every row looking at only 4, 5, and 6. Do all 9 rows. And then next you do the 7, 8, 9 in each row. And you will find a lot of singles like that. And then when you're done with that, then you do the columns and you look at the 1, 4, 7. And then you scan 2, 5, 8, and then you scan 3, 6, 9, and do all 9 columns like that. And believe me, that is the easiest way to find hidden singles. Then you should also scan the blocks, but it's not necessary to zero in on the 3 candidates at a time when you're doing the blocks because all the cells are so close to each other. Okay, let's take a look at a few puzzles and try to find some hidden singles. So first, let's use the technique that I just showed you of focusing on 3 candidates at a time. So we'll look at the 1s, the 2s, and the 3s in all the rows. And that's what we do first. So we go to the top row and we see that there is a 2, 3, 3, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. So there are multiple instances of each of those candidates in row 1. So we know there is not a single on any one of those candidates in row 1. And that's how you do it. Then you go to row 2, 3, 2, 3, 2, 3, 2, 3. So there's multiple instances of each candidate, and it can't be a 1 because there's a 1 here in the first cell. Now the thing of it is as soon as you see a second one of any of the candidates, then you know that that's not it. And you can, if in a split second, you mentally say, well, there are 2 3s, so we know there's not going to be a 3. So then you just look for the 2s and the 1s after that. But you know, we're talking about nanoseconds in your mind, so you know, to try to get your time down. Anyway, row 3, 2, 3, 2, 3, 1, 2, 1, 3, 1, 2, 3. Still no singles. So now let's just cut to the chase here, and we'll go down to row 8, and we see it's 3, 1, 3, 1, 1, 3. So there's no single there. The 2 is already placed. So there's multiple 1s and multiple 3s. So there's no single there. And then we look in column 3 for the 1s, 4s, and the 7s, and we see this 1, 1, 1, 1. There's all 1s. So it doesn't seem like there's anything on the 1. But if you have a keen eye, which is what you're going to need if you don't have filters, you will see that this one here in row 8, column 3, is the only one in block 7. Now, if you turn your filters on, that's going to show up just like that. It's just obvious that there's only one candidate 1 in block 7. But there are multiple instances of 1 in column 3, and there are multiple instances of 1 in row 8. So by doing the rows and the columns, you're not going to find that one. But this one up here in column 2, you see this is the only one in column 2, even though there are many ones in row 4, as we just saw a minute ago. But if you look down this column for 1, 4, 7 in column 2, 4, 7, 4, 7, 1, 7. So you see there's multiple 4s, multiple 7, but there's only one 1. So by that, you know you can solve that for the 1, and you can solve that for the 1. Those are hidden singles. Now let's go back and we'll look for other candidates in the same puzzle. Now let's take a look. Let's do the 4, 5s, and the 6s. So we start in row 1, 4, 6, 4, 6, 4. There's multiple 6s and multiple 4s, and the 5 is already solved here. So there's only going to be candidates of 4 and 6 left in that row. And the next row, 5, and that's it. So there's a 5. That's a single 5, and we know that that is the solution because that's the only 5 in row 2. Now let's turn on the filter, and we see that that's the only 5 in block 1, and it's the only 5 in row 2. But there, if we had looked down the column, we'd have seen 3 5s. But that doesn't matter. This 5 is the only 5 in block 1, so that has to be the solution for that. And then again, down here, the filter shows you that this is the only candidate 5 in row 7. So that is also a hidden single. Now, and then we see there's a naked single on a 5 that we can solve immediately after that. Okay, so let's go back to the same puzzle and look for the 6s. And if we look at the 6s in the first row, 4, 6, 4, 6, like we did before, there's 2 6s. And then we go down column 3, and we see it's 3, 6, 3, 3, 3, 3, 3. There's only 1 6 in column 3. Now, that's not how you would do it. You do them in sequence. I'm just cutting to the chase because it would take hours to show this demonstration if we were going down every single column. But if you do them all one at a time, you would have come to the point where you were going down the 3s, the 6s, and the 9s in each column, and you do column 1, column 2, and when you get to column 3, you see that there's only 1 6 in column 3. And if you turn the filters on, you can see there are 2 6s in row 1, and there are 2 6s in block 1, but there's only 1 6 in column 3, and that's the secret. So that is the hidden single there. So like I said, the blocks, when it's just a single candidate in a block, it's a little harder to see, especially without the filters. Okay, let's go to the next example. In this puzzle, we're going to focus on the 2s, the 6s, and the 9s. So let's go up to row 1. We see there are 2 2s in row 1. Row 2, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, nothing there. 3, 3, 3, 3. Row 4, 1, 3, 1, 3, 3. Row 5, 3, 3, 2, 3. That's the only 2 in row 5. So let's turn on the filter, and we see that it's the only 2 in block 5, it's the only 2 in row 5, but there are 2 2s in column 5, but like I said before, that doesn't matter. This has to be the solution for block 5. And it has to be the solution for row 5, so you can just fill it in like that. Okay, let's go on to the 6s. So the 6s, we go through the 4, 5, 6, 4, 5, 6. Here's a naked 6, but we're not talking about that right now, so try to ignore that. 5, 6, 5, 6, 4, 5, 6, 4, 5, 6. 5, 6, 4, 5, 6, 4, 5, 6. 5, 6, 5, 6. And now in row 4, we see, boom, there's only candidate of the 4, 5, and 6, because the 4 and the 5s are already filled. So there will only be 6s left, but there's only 1. And there it is. So that is the only 6 in row 4. Now let's turn on the filter. And we see it's the only 6 in row 4. It's the only 6 in block 4. But there are many 6s in column 2. But as we know, that does not matter. That is the solution for that cell. And that is a hidden single. So let's move on to the 9s. We see in row 1, 7, 7. Next row, 7, 7, 8, 7, 8, 7, 8, 9, 9. And then 8, 8, 8. Row 4, 7, 8, 7, 8, 7, 8, 9, 7, 8, 7, 8, 9. So we just keep going, 7, 8, 7, 8, 7, 8. Finally, we come down to row 8, and we see it's 7, 8, 7, 7, 8, 9, 8, 7, 8, 7, 8, 8, 8, 8. There's only 1 9 in row 8. So let's take a look, and you don't have to go any farther. You don't have to do the columns to find that 9, because it's this only 9 in row 8, so it has to be the solution. And so we see that not only is it the only 9 in row 8, it's the only 9 in column 3, and it's the only 9 in block 7, so that is a 9. All right, next one. Okay, here we're going to zero in on the 3s, the 5s, the 6s, and the 9s. So we look at the 3s, and we see that there aren't any in row 1, and there's several in row 2, and there aren't any in row 3, there aren't any in row 4. In row 5, there are several. But if we continue on, according to the method I showed you earlier, eventually you're going to get to the columns and you're going to do the 3s, the 6s, and the 9s. So let's go down column 8 and look for 3, 6, 9. That's the far right column. So nothing there than 6, 3, 6. That's it. So there's only there's 2 6s, but there's only 1 3. So that has to be the solution for that cell. Now let's turn on the filters, and you will see that it is the only 3 in column 8, and it is the only 3 in block 6. All right, so now let's move to the 5s, and we'll save you the trouble of going through all the rows. Let's go down here to row 8. We see it's 4, 5, 4, 4, 4. So we know that that has to be the solution for that cell. And we turn on the filters, and we see that it is the only 5 in row 8, and it is the only 5 in block 7. Now for the 6s, let's just turn the filters on right away. Okay, we see there's one down here in row 7. That is a hidden single because it's the only 6 in row 7, and it's the only 6 in block 9. And this is the only 6 in the row, the column, and the block. So that has to be a 6. And now this is the only 6 in column 9. So you can solve that, and then that leaves this as the only 6 in row 2, block 1, and column 2. So you solve all 3 just like that. Boom, boom, boom. Okay, let's move on to the 9s and turn on the filter. And we see that there are 3 9s in row 1, and there are 2 9s in column 5, but there is only 1 9 in block 2. So that has to be the solution to that. And then further, we see this 9 over here in row 8 is the only 9 in block 9, and it's the only 9 in column 7. So that must be the solution to that cell. All right, next. Okay, so here we're going to look at the 1s and the 5s. So we go up to row 1 and look at 1, 2, 3. We see it's 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. So as soon as you see 1, 2, 3 twice, you know they're all multiples. So now let's cut to the chase and look down column 3 and do the 1, 4s, and the 7s vertically. We go 1, 4, 7, 7, 7, 4, 4. So there's multiple 7s and multiple 4s, but there's only one candidate 1. So we turn on the filter, and sure enough, that's the only one in column 3, and it's the only one in block 1, so that is the solution to that cell. That is a hidden single. All right, let's move to candidate 5. In row 6, we have 5, 6, 5, 6, 6, 6, 5, 6. So there's multiple instances of each candidate in that row. But now, let's look in column 9, and we see 2, 5, 2, 5, 2, 5, 2, 5, 2. Okay, so we know there's multiple 2s and multiple 5s, so that is not the answer. But if you have a good eye, you can look in block 6 and see that there is only one candidate 5 in block 6, as the filters will show. And that is a hidden single and is the solution to block 6, regardless of this 5 up here in column 9 and these other 2 5s in row 6. That is the answer to that cell. Now another thing you want to be looking for as you're looking for these singles is conjugate pairs. Because when you're going through the rows and the columns, and even the blocks, but more so in the rows and the columns, if you see 2 instances of the same candidate, exactly 2, not 3 and not 1, but 2, and not any more than 3. But if you see exactly 2 instances of a candidate in a row, a column, or a block, that is a conjugate pair, and they come into play in a myriad of the solving techniques that we will be learning. So you need to keep your eye out for those at all times, and when you're scanning for these singles, if you see a conjugate pair, just remember where it is, because you may need it later on. Now, for instance, let's take a look at the ones here in this puzzle. Let's light them up. So we see there are only 2 ones in row 1, here and here. And that is a conjugate pair. Now forget about this one down here. These 2 up here in row 1 are a conjugate pair. They're the only 2 ones in row 1. And there's a strong link between them. And again, down here, between this one and that one is a conjugate pair. There's a strong link between them. Notice what they look like. It's like a bar of 2 in a row or a column. Like for instance, here, this is also a conjugate pair and a strong link. There's just 2 ones in column 5. So that is a strong link between the ones, and that is a conjugate pair. Now there's also a strong link, and it's a conjugate pair between these 2 ones in this block, but they're not as easy to see when you're scanning, especially when you're scanning rows and columns. But if you're careful, you'll see that. But the ones that you'll be able to see more easily are the ones in the columns like that, or the ones in the rows like that. So keep your eye out for them because they're very important. Now I showed you how to do the scanning of the 3 candidates at a time, but here in this last puzzle, I'm just going to go straight to the filters because we need to wrap this up. So let's undo that. Now let's take a look at the 2s in this puzzle. And we can see that there are immediately 3 hidden singles that show themselves. We have 1 here in block 1, and there's another 2 in row 2, but it doesn't matter. This is the only 2 in column 2 and the only 2 in block 1. And here, this is the only 2 in row 6, column 7, and block 6. And this 2 is the only 2 in row 8. So you can immediately solve those 3 2s, and as you can see, it leaves the remaining 2 up here to be solved. Okay? So let's undo that. And now let's go and look at the 3s. So we see there is a solo 3 up here in block 3. You can solve that, and there is a solo 3 here in block 4, and you can solve that. As soon as you have one house, as soon as a candidate is the only candidate in a house, a row, a column, or a block, you don't need anything else. These 2 were candidates in yet another house, but we didn't need those. As soon as you see it's the only one in the block, you can solve it, and if you can see this is the only one in the row, you can solve it. You don't need to see anything else. You don't have to go any farther and don't waste any more time. Okay, so now let's take a look at the 4s. And we see in here in column 9, there's the only 4 in column 9, so you solve that, and then here's a naked 4 down there. And then here's another hidden 4 up here. So see, they kind of breed each other. Once you solve one, many times more will come along right away. All right, let's take a look now at the 5s. And we see that there is a solo 5 down here in row 8, so you can solve that. And then lastly, we'll take a look at the 8s. And we see that there is a single 8 in column 1, and there is a single 8 in row 9, and then now there is a single 8 in column 2, leaving what's called an X-wing that we'll talk about in another video. Okay, now let's move on to the naked singles. And last but not least, we have what's called naked singles. And these are by far the easiest ones to find. The explanation of how these are created is a little more complicated, but let's go through that right now. The first way is by virtue of what we call a full house. And as you know, that's when 8 of the 9 digits appear in any house with only one cell left. Like in row 2, we know that this cell has to be a 6. And down here in block 8, we know that this middle cell has to be a 5 because that's the only one left. And the house has to have all 9 digits. So if there's only one missing, it can only be one possible choice. And the second way is similar to a full house, but all the other 8 digits do not lie in the same house, and it's some combination thereof. Like this center square here, it can see the 1, 2, 3, 4, 5, 6, 8, and 9. So we know that this cell must be a 7, and that's going to show up like that as a naked single because it can see all instances of the other 8 digits. And the third way is when you have eliminated all but one of the candidates in any particular cell by virtue of using all the different solving techniques. Now, if you're doing the puzzles with pencil and paper, you have to be very careful to keep your candidate lists up to date, or you could make a mistake. Now, when you're doing it on a computer and you have automatic candidate lists, when you see a single candidate in a cell, that will be a naked single, and it will not be a mistake. So let's go through some puzzles, filling in the naked singles, and see how many we can get. Okay, in this puzzle down here in row 8, we see there's a naked 3. See, that's the only 3 in that cell. That has to be a 3. Then up here we see that's a 5. Up above that is a 7. Right next to it is a 9. Down here is a 7. Down here is a 4. Here is a 6. And I think that's it for this puzzle. All right, let's go to the next one. We start here as a 3. And over here is a 4. Down here is a 5. Down here is a 9. Here's an 8. Are there any more? I don't see any more in this puzzle. Okay, we'll go to the next one. Okay, here we have a naked 1. And then a naked 9, a naked 8, a naked 7, a naked 6, 4, 5, 9, 3, 8, 7, 6. Let's see, there's a 9. And you probably see more than I do. Here down in the row 9, there's a 5, and a 1, and a 3. And let's see. All right, let's go to the next one. Here's a 3, there's a 7, a 3, a 1, a 1, a 9, a 6. Here's an 8 over here. And I think that's about it for this one. Okay, I'll go to the next one. And it's an 8, a 5, a 3, a 6, 8, 2, 1, 9, 6, 5, 6, 7, 1. These are so easy to see, especially with a computer. You just see a lone candidate in a cell. All right, let's take a look at this last one. 1, 2, 6, 4. And then every time you fill one in, it creates new ones. Okay, so here's a 4, here's a 5, 9, 1, it's an 8, 5, 7, 3, 9, 8, 7, 4, 3. Here's a 4 over here, 7, 1, 5, 4, 2, 1, 9, 6, 5, 9, 6, 4, 2, 1, 9, 8, 2, 1, 7, 5, 7, 3, 6, 8, 2, 6, 3, 5, 8. We solved the whole puzzle with naked singles. Okay, that should give you a pretty good understanding of how these work. So in the next video, we're going to move to the more interesting solving techniques with locked candidates. And I hope to see you then. That'll be video number 6. So let's go back outside and finish up for today. Thanks for watching. Okay, that's it for today. I trust that by now you can find all the different types of singles with not much effort at all. So good luck, thanks for watching, and I'll see you in videos number 6 and number 7 on locked candidates. Until then, be well and be happy.